Hey, it's Alien Machine AI here with my fresh Comfy install. And what I want to do is take a look at what it will take on this new fresh install to set things up and make a basic Canny ControlNet workflow. I'm not sure exactly the steps to take. We're just going to wing it. And I've done this before, so let's see. We have the ControlNet models that can be found on Civet AI from the Ally user. Uh, these are the T2I adapter models, and we can find the ControlNet models, all of them compiled, which is a lot of work on the Civet AI article, Civet AI Guide to ControlNet Part 1 Basics, which is an excellent guide, the best, most comprehensive guide so far that I've found that at least has the listing of models compiled. We have the ControlNet SD 1.5, T2I adapter SD 1.5, and I think I'm going to use SDXL today, which means we are going to use these models. I chose to do Canny for today, and we will need to find the model for ControlNet, and here we have all the different models going across, and we need to find the one we want. There's all different versions. We need to find let's see. There are a ton of models, different choices. Let's try Tenant Arc Canny. We are going to hit download. On this Canny ControlNet SDXL model. It's about 150 megabytes. And we need to place this in the ComfyUI directory, the models directory, ControlNet, and we're going to put SDXL to help organize this for later. And we have Comfy in this other panel. We're going to create a new workflow, save as ControlNet Canny Alien Machine AI. And now we're going to start to hopefully build our workflow and see if we need to download additional models and how to. So, how do we go about making the workflow for ControlNet? Where do we start with any workflow? It's always just a mystery where to start. You need to just place something, and it will start to come together one piece at a time. And you can just keep flowing, and you'll get in a flow of placing nodes, connecting them, seeing what they need, what you can adjust. And it's once you're just moving, it's a lot easier. And so we're building a control net, and this is where we might hit a snag because I don't have custom nodes installed. I have very few nodes installed, as you'll see here. We have the manager, you know, 1,654 available. I have 6 custom nodes from my last videos already installed. I'm making a new install to weed out and de-bloat my install. So I'm bringing you guys along for the ride as I refill myself with nodes. I'm in the manager and I've identified at least one node we might need for this project. The ControlNet auxiliary preprocessors will supply preprocessing of images before being sent to ControlNet. You need to modify the input data and pre-process it before it is sent into the ControlNet itself. It starts as a raw image. You process it with whatever you need. You need depth, or you need a Canny data, or whatever you're working with. So let's install this. Another node that we may need is the ComfyUI Advanced ControlNet node. Hopefully this will supply the nodes Advanced ControlNet Apply, Advanced ControlNet Load. Don't forget to refresh the page after you restart your server completely fresh. Close the CLI completely and reopen it fresh. Don't just stop the server and restart it, or you'll throw an error sometimes. So let's see if we have the nodes we want. Here we go. We installed the load advanced ControlNet model. There's also load ControlNet model. Load advanced ControlNet model can take an additional input of the TK optional input, and you can use a different node and control some variables using that additionally, compared to the load ControlNet model, which only loads the model. So we will use this. We will want to have the apply advanced ControlNet node, which is the main node for this. And here it is, nice and big. We have positive conditioning, negative conditioning, and that's what's going to be given out is positive and negative conditioning. So the control net is taking in the conditioning, taking in an image, and using the control net model that we give it. And it can be a variety of models. You need to have the image data that is pre-processed. Okay, so we're going to pre-process, and let's see if we have the Canny preprocessor. We have the Canny Edge node, okay, from the ComfyUI auxiliary preprocessors node. And this takes some other inputs optionally, like the VAE and model. I don't know what effect it has to actually give that versus not give that. Maybe somebody can fill me in the comments on the specifics of the model optional and the VAE optional. I just fill them in, but it depends exactly what you're doing if you need to do that, really. So far, I've always just filled them with what I'm uh, already providing in the workflow. If I'm using SDXL, which we're using today, we have the ControlNet XL model, and you need to have the specific one for SD 1.5 or SDXL or other. So this is the ControlNet input. We're going to connect this node to the ControlNet. This is the Canny Edge preprocessor, and we need to load the image, which is going to be preprocessed, into the Canny Edge. We have the load image node here, connect it to Canny Edge, and we will just use, what image do we want to use? We're going to have to find an image, or actually, and we want it to be the right resolution and such. Speaking of which, we want to change this resolution on Canny Edge to 1024 because I'm working with SDXL. It uses 1024, 1 megapixel of pixels resolution. So you want to make sure things correspond resolution wise to what you're working with. This will go to here. I still need the image, but that's an afterthought. The images are actually the afterthought. I'm so just wrapped up in the workflows at this point. And we're going to need to create a conditioning. We're going to need to have the actual generation as well. So let's do load checkpoint. And we can connect the model optional right away. We'll use the baked, we'll try everything baked VAE wise. And we're going to have clip into some text. We're using SDXL. So we're going to want clip text encode SDXL today. And we'll just use the baked clip to start. See if that works okay. This one is for the positive conditioning. And this is good because it has text G and text L. You can specify different ones. You can specify different prompts, for each text G and text L for both positive and negative with this workflow we're building right now. Okay, so we have connected this text conditioning encoder into the apply advanced control net. And this apply advanced control net is modifying the conditioning, and we're going to pass it on to our sampler with the conditioning that is modified. The data based on the initial image that we're going to give it. We're going to find a good image, not the standard Comfy one. I would just run it, but I don't think it's actually here. Maybe it is. But we also want it to be a proper resolution. But before we worry about the image, we'll finish building the workflow, and then we can actually run the image. So we have the conditioning, the control net, And I'm betting on having picked the right control net, honestly. There was a lot of options on the Civet AI page from the very generous individual who's compiling them and managing that page. We have tenant art Canny. It's going to make a resemblance from the image based on picking up edges. Canny edge, it picks up edges, uses this high threshold. To be more sensitive, you turn it down. You want this set to the proper resolution. The low threshold can be adjusted, and that these adjustments will define how detailed the image and how closely it resembles the. So we are going to want a K sampler. Let's see what we can choose. We're going to use K sampler efficient. We are going to put the model input into the node. You're going to supply the positive and negative conditioning to the sampler, which has been modified by the advanced ControlNet node. You need a latent image. Let's connect the VAE first while we're at it, and we'll see how to handle latent images with XDXL. And the pitfall is having the wrong resolution in stable diffusion. You want to have the right number of pixels in the latent image. It needs to be divisible by 64. However, it also needs to have a total of 1 megapixel of data for SDXL. You want to have the equivalent of 1024 1024 pixels on each side. It can be a different ratio, but it needs to have the number of pixels the same. And I have my old school solar powered calculator right here. Let's find out how many pixels. 1024 multiplied by 1024. Wow, that's a lot of pixels. Let's see if that's even my calculations right. I thought my calculation was off. 1024 multiplied by 1024 resolution is 1,048,576, I believe, pixels. That is a lot of pixels. So we're going to need to have that many pixels in our image that is input, and it will output that same number of pixels. Let's see what we have here. So we need the latent image that fits the number of pixels. It's divisible by 64. The ratio should be something like 16 to 9, 4 to 3, a square 1 to 1. But instead of empty latent image and defining this explicitly here, what we're going to do, and this is where the power of ComfyUI starts to come in and you start to figure things out and what you can do with it. Convert widget to input. Convert width to input, as well as the height to input. This will allow us to provide the width and height using a different node. And we have resolution providers such as JPS nodes, SDXL resolutions, which is the one I've been using lately. This will allow us to have square, landscape, or portrait. It has different ratios, and it has the proper number of pixels, all optimized for SDXL. And if you're into graphic design, you know anything about, let's say monitors, screens, 16:9 is a standard widescreen resolution for TVs and monitors, unless you have an extra wide 16:10 or something special and you're lucky. Um, you're going to want your image to be in one of these standards for people instead of just an odd size that it'll look fine, but it's not going to fit perfect. It could be better if you're not in a standard ratio, in my opinion. So we have the sampler. We're getting close. Steps. We're going to try to just leave this for now. We'll just use one sampler. And the K sampler efficient from the efficiency nodes allows the daisy chaining into other samplers if you want to use multiple samplers. You have image, preview image, so we can preview it. And you want to have a save image if you want to save it. We'll show that. And you can customize your prefix so you can find it later. And it looks like this is getting close for now. If the Canny model is right, this might be getting close. You want to connect the latent to the sampler with the width and height of the latent provided by the SDXL resolutions JPS node. So it's a lot easier because you're not manually inputting resolutions and having to remember the right exact numbers. There are other nodes for resolutions, but this is the one I found best so far. Now, to help us troubleshoot and maybe to just run the workflow, we are going to just try running it and see where we hit a snag. We do want to consider in a moment perhaps the width and height, target width and height. I've been setting these the same way, convert the widget to an input and provide the width and height using this SDXL resolutions JPS node. We are going to give it a prompt. I like to start the prompt with language in the context or perspective of saying the image displays, because it's natural language. If you give it like a search engine, old school search engine type jumble of words, it might not work as well as if you explicitly use natural language. It's using, natural language processing oftentimes. So if we use natural language, it can decipher it and actually see what we mean better. It will work if you give it word salad, but because it'll make inferences from the data and use the neural networks, use weighting based on the data you give it, and give outputs based on the weighting. And so you'll get an output, but we want to have natural language to make sure it's more explicitly obvious to the stable diffusion models and take that and the conditioning we provide. Okay, so that's enough of that rambling on. We're going to give this a prompt. The image displays a dystopian future setting image with surreal elements and vivid, colorful, swirling lighting, illuminating a figure of a mature older woman. I found honestly you'll get young subjects unless you explicitly say
mature older individuals and accentuate that they're old. And that's just a reflection of societal biases within the stable diffusion models, in my opinion. But and we need to copy this. This is the positive. I like to give everything colors, especially this is important. It makes it easier to see your prompt area. You can now see that is the prompt. This is the sampler, and we want to have the same prompt in text L and in text G. Text G, or the negative prompt, will say the image displays anything considered. Just something quick, disfigured, or an error, or a rejected image, or nudity, or NSFW. And honestly, I know I'm not doing the prompting correct. My interest right now is to work on the workflows, work on the technical aspects, and the prompting is almost an afterthought. The images I'm getting are almost an afterthought. I'm interested in the technical aspect, and I can create the images if I am in the mood to create art. If I want to make a nerdy project, I can work on making complex, huge workflows and integrating multiple workflows to something huge. This is only a basic boilerplate template, so we're going to next see if this runs. It almost looks like it'll just run if the ControlNet model is proper. Okay, here we go. Pressing start. We're using albedo base XL large, safe tensors, STXL merge model. We could also load next the dual clip loader. I'll show you while this is loading the model. It takes a second to load in. I'm on a 3090 GPU. It's 24 gigabytes of VRAM is helpful. I upgraded from a 3080 and I just swapped in the new GPU without having to build a whole new rig. And it's really furthered my ability to run stable diffusion. I had been training low range adaptation models, lower models, on my 3080 and was limited. So I upgraded to the 3090 used. And here we are. I've used up to 21 gigabytes of VRAM in my large workflows that I am not showing yet, where I have just used multiple control nets, multiple T2I adapters, and all different technologies, and experiment with integrating them. And, sorry as I ramble on, this is just loading. Okay, here we go. It is sampling based on the ComfyUI basic image. It worked. We're successful. Look at that. It's nothing amazing, but we only gave it. Look what we gave it. It's making that based on this. So our new image is more impressive than the ComfyUI default. We have this. And does it follow the prompt? Vivid, colorful, swirling lighting, surreal elements. Yeah. Dystopian future, you can see this here. It's like a cityscape element with kind of like a neon dystopian lighting. of buildings on a street that you can just barely make out. That's the dystopian element. Swirling lighting. It's using the ComfyUI image we gave it and picking that up and transferring that resemblance of the canny edge data, which was pre-processed, into the apply ControlNet node, supplying modified conditioning to the sampler, and giving us this new image. Here's another image. It's an image I made, I think, using Flux and Flux low range adaptation models. What we're going to do is run this kind of complex and detailed image. It's the image I'm using as the avatar on YouTube for Alien Machine AI. And we're going to just see what happens to the data we provide, how it was modified, and it passes in to the sampler using ControlNet. I think it'll be an interesting image to use. And it's the same ratio, it's a square. You want to use the same ratio or be prepared for distortion. Here we go. And you can see it's using the image. It's making something different. Some may prefer the original image, but that's not the point. You're supplying an image knowing it's going to be modified and give you a different output, so you're strategically choosing which ones will give the most interesting output. And as you learn the particulars of how the image will be modified by Canny ContolNet, you can more effectively choose images and know which will be best. If you choose something abstract, you'll get an abstract output. And that's oftentimes what I'm looking for, is something very artistic. It doesn't have to be realistic. If you want something realistic, you can achieve that using the right model and the right techniques and the right prompt. If the model is trained on digital art or illustrations, that's what you'll be more likely to get. Here with the base model input that is given to the sampler, also to the ControlNet. And there you go. That's the basic workflow for ControlNet from scratch with Alien Machine AI.